Good morning, children. So we have started quadratic equations, and in the previous lecture I had said that for quadratic equation ax square plus bx plus c equal to 0, where a is not equal to 0, if alpha and beta are the roots, okay, are the roots, then sum of the roots, that means alpha plus beta, will be minus b upon a, and product of the roots will be c upon a. So I had discussed this, and we had solved a few questions. I had given you homework also, few of you have done, and so let us proceed now. So next question, this had come in ISC 2019, and the question says, given that alpha and beta are the roots of the quadratic equation this px square plus qx plus 1 equal to 0. So this is the quadratic equation, and roots are alpha and beta, and here you can see that p is your a, q is your b, and plus 1 is your c. Okay, and what we are supposed to find? We are supposed to find alpha cube into beta square plus alpha square into beta cube. Okay, so firstly what we will do is, since we have been given a quadratic equation and they have already said that alpha and beta are the roots, so firstly we will find the sum of the roots and the product of the roots. Okay, then only we will proceed with this expression. Okay, so solution: given px square plus qx plus 1 is equal to 0. Here your a is p, your b is q, and your c is 1. Therefore, sum of the roots, that means alpha plus beta, because they have said that alpha and beta are the roots of this. I have not mentioned over here. Okay, so sum of the roots alpha plus beta will be what? Minus b upon a. So here b is how much? Q. So we'll put q upon p. So this implies alpha plus beta is equal to minus q upon p, and product of the roots, that means alpha into beta, will be c upon a. Here c is 1 and a is p. Okay, so this implies alpha into beta is 1 by p. So now you know the sum of the roots and you know the product of the roots. So these two information will help you to find the value of this. Okay, so I will write it now. Now alpha cube into beta square plus alpha square into beta cube can be written as, here you can see that in both the terms alpha square is common and beta square is common. So alpha square into beta square comes out. So in the first term you are left with alpha, and in the second term you are left with beta. Now this alpha square into beta square can be written as alpha into beta whole square, yes, into, here we'll write alpha plus beta. Now alpha into beta we have found 1 upon p, and your alpha plus beta is minus q upon p. Okay, so here 1 upon p whole square will be 1 by p square, and this minus is there, so this 1 into minus q, minus will come outside. Okay, and here you are left with q upon p, so you can write minus q upon p cube. Okay, so this is the answer. Okay. Okay children, so now we will see the next topic, and here we will discuss how to form a quadratic equation, formation of quadratic equation when roots are given. Okay, so in class 10 equation was given, quadratic equation was given, and we used to find the roots. But now here we are going to do reverse. Okay, means roots are going to be given to you and you have to find the corresponding quadratic equation. Okay, so suppose you have been given roots alpha and beta. Okay, and you have been asked to write down the corresponding quadratic equation for these roots. Then it will be written as x square minus alpha plus beta into x plus, here it's not visible, I think it is alpha into beta equal to 0. Okay, so it means x square minus sum of the roots into x plus product of the roots. So I think once we see the example, this will be clear to you. Okay, so suppose I want a quadratic equation whose roots must be 2 and 3. 2 and 3. So what would be that quadratic equation whose roots are going to be 2 and 3? Okay, so how we can find that? We can find using this. Okay, x square minus, so we'll write the required quadratic equation is, so here you can see what you are supposed to write. Firstly we'll write x square, then minus, then sum of the roots. So sum of the roots mean here what do we want as roots? We want 2 and 3, so sum of the roots will be 2 plus 3 5. Okay, so 2 plus 3 into x, then plus, then we have to write product of the roots. So for the required quadratic equation, roots should be 2 and 3, so product will be 2 3s are 6. So okay, so this is going to be the quadratic equation which will have 2 and 3 as its roots. Okay, so now we will see questions, okay, where roots are going to be given to you and you are supposed to find the quadratic equations. Okay, and your maths copy you will write this formation of quadratic equation when roots are given. Okay, and here I think this is not visible to you, this is not visible to you, this is alpha into beta. Okay, so now we will see a few questions. Okay children, so now let us see this question here from page 269, part B, question number 4. Find the equation whose roots are, means we have to form the quadratic equation whose roots are going to be this. Like for the first one, 3 by 4 and minus 2 by 5. So number 1, solution. Given the roots R. Let's say I'm denoting one by alpha and the other one by beta. So roots are given to us. Now we have to find the corresponding quadratic equation. Okay. So for the roots alpha and beta, the required quadratic equation is, that is, x square minus sum of the roots. So here sum of the roots means alpha plus beta into x plus product of the roots, that means alpha into beta equal to 0. Okay. Now substitute the values. So x square minus your alpha is 3 by 4, beta is minus 2 by 5, and here 3 by 4 into minus 2 by 5 equal to 0. Then x square minus, here LCM of 4 and 5 is 20. Okay, so simply we'll get here 15, this plus and here minus, so minus. Okay, and 8, and down we are getting 20, this x. Here plus, here minus, multiplication is there. So plus into minus, minus. We cannot cancel anything over here. So multiply. So 3 2 is 6 and 4 5 is 20 equal to 0. Next, here you can see that in denominator we have 20, here also 20. So I can multiply throughout by 20. So we'll get rid of this 20 in the denominator. So multiplying both the side by 20, I get 20 x square. And here when I multiply by 20, 20 20 cancel, and 15 minus 8 will be 7x, and here this 20 cancelled. Okay, so this is the required quadratic equation, which will have roots as 3 by 4 and minus 2 by 5. Okay. Okay, now let us see the second one. So here roots are given as 2 plus root 3, okay, and 2 minus root 3. So you try this by yourself. I will do the third one. Here it's saying roots are 3 plus 2i and 3 minus 2i. Okay. So I'm doing the third one. Second one you are supposed to do by yourselves, same as first one. So given roots are, and here roots are 3 plus 2i, 3 plus 2i and 3 minus 2i. Okay. We are looking for a quadratic equation which will have 3 plus 2i and 3 minus 2i as roots. So the quadratic equation for given roots is, so here roots are given. So if roots are given, then quadratic equation will be this: x square minus sum of the roots, yes, sum of the roots into x plus product of the roots. Okay. Here you could have taken this to be alpha and this as beta. Okay. Now let us substitute the values. So we get x square here minus and 3 plus 2i plus 3 minus 2i. Yes, these are the roots, and here we have to take product of these two roots. So 3 plus 2i into 3 minus 2i equal to 0. Here open the bracket and you will see that plus 2i and minus 2i will get cancelled, and 3 plus 3 6x, and here this is like a plus b and here a minus b. Yes, so product will be a square minus b square. So we will get 3 square means 9 minus 2i square means 4i square is equal to 0. But in the previous chapter, complex numbers, we have learned that I square is nothing but minus 1. Yes. So 9 minus 4 minus 1. So in the next step I will get x square minus 6x minus minus plus 9 plus 4 13 equal to 0. Here you can give the reason that I square is minus 1. Okay. You can give the reason here. And this is the required quadratic equation, which will have roots as 3 plus 2i and 3 minus 2i. Okay. Okay, now let us see the next question. Question number 5. Here it says, if one root of ax square plus bx plus c is equal to 0, be twice the other. So this is the quadratic equation. Okay. And here it's saying that one root of this quadratic equation is twice the other. Prove that 2b square is equal to 9ac. Clear? So let us see the solution. So here I will write, let one of the roots be alpha. Okay. So here I am taking one of the roots be alpha. Now can you tell me what would be the other root? If you read the question, here it says one root of this quadratic equation is twice the other. So if this is alpha, then I can take the other one to be 2 times alpha. Okay. Then the other root will be 2 alpha. This is given to us. Yes. Now next, what we are supposed to do? We have to prove this. And we have got only these two roots, and till now we have learnt about their sum and their product. So using those two only we are supposed to prove this. So now sum of the roots. Okay. Sum of the roots is equal to alpha plus 2 alpha, which will be 3 alpha. Okay. But this 3 alpha means sum of the roots will be equal to how much? It will be minus b by a. So here we have b and here a, so we'll write minus b by a. Okay. So this implies alpha will be minus b upon 3a. Leave this as equation 1. Okay. Next, product of the roots will be equal to alpha into 2 alpha 2 times alpha square. Okay. But you know that product will be equal to how much? it will be C by A. Okay, so here C by A means C by A only. Okay, so here we get C by A. This implies alpha square is C by 2A. Clear? Now from equation 1, can I use alpha equal to minus B upon 3A? So I will write, in place of alpha, I can write minus B upon 3A. So I'll write minus B upon 3A whole square. Okay. Now simplify. So you will get minus B whole square, that means B square, and down 3A whole square means 9A square is equal to C by 2A. And what we are supposed to prove? We are supposed to prove that 2B square is equal to 9AC. Okay. So I can take this 2 here on the left. So I'll get 2B square. This 9A square will go that side. So I'll get 9A square C, and down here A. So 1A will get cancelled in numerator. So 2B square is equal to 9AC. It's proved. Okay. Okay, now let us come to this question number 7. And here question number 7A. Okay, we are still on page 269, part B. So here, if alpha and beta be the two roots of this quadratic equation 2x square plus 3x plus 2 equal to 0, then we need to form an equation. Okay, first equation we have to form such a way that the roots for that equation should be alpha plus 1 and beta plus 1. And second equation we have to form such a way that the roots should be alpha upon beta and beta upon alpha. Okay. So before we that since roots are given to you, so equation for this will be x square minus sum of roots, then plus product of roots equal to 0. You know that, yes, that corresponding quadratic equation for these two roots, for these two will be given by this. Clear? So here, since we have been told that alpha and beta are the roots for this, so we need to get some information from this first, and that has to be used for these two. So let's see how we can use that. So solution: given alpha and beta are the roots of 2x square plus 3x plus 2 is equal to 0. Therefore, alpha plus beta means sum of the roots will be minus b upon a. So here what is your b? It's 3. So you'll write 3 and your a is how much? 2. So you are getting minus 3 by 2. Done. And alpha into beta, that means product of the roots, will be what? C upon a. So what is your c? It's 2. So 2 upon 2, yes, it will come 1. So this was given to us, and from there we have concluded that alpha plus beta will be minus 3 by 2 and alpha into beta will be 1. Now let's come to number 1. So these roots are given and we are looking for the quadratic equation for this. So for the roots alpha plus 1 and beta plus 1, quadratic equation is, and you know how it's written x square minus sum of the roots. So what are the roots? Alpha plus 1 and beta plus 1. So sum of the roots, that means alpha plus 1 plus beta plus 1. Okay, here inside this I'm not writing bracket because you can see all are plus plus plus, so that would not affect. Okay, then x and here plus and then product of the roots, that means I have to write alpha plus 1 here beta plus 1 is equal to 0. Now once we simplify this, no, then you will come to know why it was necessary for you to find these two first. Okay, so once I simplify this, here I'll get alpha plus beta plus 2x. Okay, and here when you multiply you get alpha into beta plus alpha plus beta plus 1. Okay, so now you can easily see this alpha plus beta can be replaced by this value minus 3 by 2. So I can write minus 3 by 2 plus 2, and here alpha into beta can be replaced by 1, and this alpha plus beta can be replaced by minus 3 by 2, and here 1 equal to 0. So here 2 is there and here 1 is there, LCM will be 2. So you get minus 3 plus 4 upon 2, and here same thing, 1 plus 1 2. Okay, so 2 minus 3 by 2 equal to 0. I could have done this in this step only, but I will do it in the next step. So here you will get how much? Minus 3 plus 4, that means 1, so half, and here here also you will get half only. Okay, so half equal to 0. Now what you can do is you can multiply throughout by 2 to get rid of this 2 from the denominator. So I can multiply by 2 throughout, so I'll get, so this is the required quadratic equation. Okay, okay, now next one is number 2. For the roots alpha upon beta and beta upon alpha. Okay, quadratic equation is same concept, x square minus sum of the roots. Yes, so sum of the roots means alpha by beta plus beta by alpha, then plus product of the roots, so alpha by beta into beta by alpha equal to 0. So here beta beta alpha alpha cancel, so you are left with 1. So next step, x square, here this can be, you can see here beta, here alpha, so simply multiply this alpha over here, multiply this beta, and in denominator just write beta into alpha. Okay, so you get alpha square plus beta square upon alpha into beta x, and here you are getting 1 equal to 0. Now here, as you can see, in denominator you have no problem. Alpha into beta, you know it's 1. Yes, so you can easily write 1. But alpha square plus beta square, you don't know the value. You only know value for alpha plus beta. So in the previous class also I told you that you should try to express the given expression, okay, either in alpha plus beta or alpha into beta. So for the denominator no problem, but for the numerator we have to do some manipulation over here. Okay, so here what I will do is, in the next step, in place of alpha into beta I can write 1. Yes, because alpha into beta we have got how much? 2 by 2 equal to 1. So here we'll write 1. So that means we don't have anything in the numerator. We have only alpha square plus beta square. Now what I can do is I can add 2 times alpha beta, and I can subtract at the same time 2 times alpha beta. Okay, and this will not affect the value of equation. Okay, so, and you can see now these first 3 terms can be written as alpha plus beta whole square. So you can write alpha plus beta whole square and minus 2 times alpha beta x plus 1 equal to 0. Next, alpha plus beta, we know it's 3 by minus 3 by 2. Okay, so we will write minus 3 by 2 whole square and 2 into 1, because we know alpha into beta is 1, plus 1 equal to 0. Then x square minus 9 upon 4 minus 2. Now here LCM is 4, so you get x square minus 9 minus, here 4 to the 8, and down you are getting 4. So in order to get rid of this denominator 4, I can multiply throughout by 4. So I'll get 4 x square. When you are multiplying here, 4 cancel, 9 minus 8 will be 1. Simply x you can write, and here you are multiplying throughout by 4, so this will become 4 equal to 0. This is the required quadratic equation, which will have root as alpha upon beta and beta upon alpha. Okay, so question 7a I have done it, and B will be your homework. Okay, I have written down the answer also, so you can, after solving it, you can verify. Okay, so this is all for today.